Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to subscribe and share my videos to your friends and to your friends' friends. That's the only way you can help me promote my channel and to keep me going, refreshed and inspired. And I'm very willing to share my knowledge, especially topics in civil engineering for your benefit. Concentrated load is applied to the beam with built-in ends. Find all the support reactions and draw the bending moment diagrams. So here is the beam. This is supposedly statically indeterminate to the third degree, but because AX and BX 0, we can reduce this to just 2 degree of indeterminacy. And when we apply the double integration method, there will be two unknowns also, MA and MB. But because of symmetry, MA equals MB. So this is the expected elastic curve. Of course, by symmetry, this is half of B, half the load. This is also P over 2. So AY equals BY are found P over 2. MA by symmetry equals MB. So let's assume moments to be positive at A and B. Then let's section this portion. So the boundary conditions to address MA and MB would be that uh, Y prime is 0 at B and Y is 0 at B. So there will be no C sub 1 and C sub 2 because when X is 0, Y prime is 0 and Y is 0 at A. So EI Y double prime is the moment at this section here. So moment A equals moment B by symmetry. EI Y double prime equals P over 2 times X plus MA, then minus P times quantity X minus L over 2. Integrating EIY prime equals P over 4 X squared plus MAX minus P over 2 quantity X minus L over 2 square. As I said, there's no C sub 1 because the slope at A is 0. EIY equals PX cubed over 12 plus MAX squared over 2 minus P over 6 quantity X minus L over 2 cubed. There's no C sub 2 because when X is 0, Y is 0. Then when X is L at B, Y prime is 0. So 0 equals PL squared over 4. At midspan, because the maximum deflection occurs at the midspan, the slope here is 0. So substitute here with X L over 2. So P times L over 2 quantity square over 4 plus MA times L over 2. And this is 0. L over 2 minus L over 2. So from here, we can now solve MA, which is equal to MB, negative PL over 8. Then AY equals BY equals P over 2. We already addressed that. And let's now draw the bending moment diagrams. Let's determine the moment at the midspan first. We will call that M and the shear as V. So remember, M is considering the left section, clockwise moment minus counterclockwise moment. So M equals P over 2 times L over 2 plus MA, which is negative PL over 8. So M at midspan is positive PL over 8. So the moment diagram can now be, bending moment diagram can now be established, can now be drawn. Start with negative PL over 8 here. And we just have a straight line. Then the moment here is PL over 8, also positive PL over 8. Then back to negative PL over 8 at B. So that's it for the bending moment diagram. So negative PL over 8 because this is P over 2, so negative PL over 8 plus P over 2 times L over 2 is PL over 4. That's why we have PL over 8. And that's it.